Hi everyone, so my name is Jonas Rosland. I work as a developer advocate at EMC. If you have any questions around what I'm talking about during the session or want to reach out to me afterwards and discuss more, please hit me up on Twitter. I'm at VirtualSwede. I got a blog over at purevirtual.eu for Europe. And at EMC, we also have a new initiative of open sourcing and being more inclusive in the open source community. So you can look up our website there at emccode.github.io. Short introduction about me, who I am and what I do. I love automation. I've been using Razer and Puppet for about 2 years, a little over 2 years. Razer was actually the gateway drug for me getting into Puppet. So I started with Razer before I started with Puppet because I thought deploying servers is really, really cool, but then I wanted to see what we could do after that as well. And then I got into Puppet and configuration management. I spend way too much time playing with new tools. There are so many new tools coming out in the open source community every day. I've seen a bunch of really cool stuff here at the conference as well, and I can't wait to get home and play around with it. Other stuff that I do as well, I'm a retro and indie gamer, so if you want to come up to me and talk about gaming after this, I'm all for that as well. So, a quick primer on Razer and what it is and what it does before I show you what we can do with the stuff that I developed and published a few weeks ago. Razer is an awesome provisioning tool for servers, both physical and virtual. It doesn't really matter whether or not they're physical or virtual because it's all policy-based. So we can deploy operating systems looking at CentOS, Debian, Ubuntu, SUSE, and others, even Windows if we wanted to, with this. There is no manual labor needed except, of course, the physical racking and cabling of servers and equipment. But other than that, you can just turn on an entire rack, go off, have a coffee, and when you're back at the office, everything will be provisioned. You don't even need to find the MAC address or something or anything like that on your server to be able to provision it. So it's a really powerful provisioning tool for all your server needs, both physical and virtual, in your entire data center. So you just create a policy and boot up your servers and away you go. So what's in a Razer policy? We'll look at policies when I'm doing a demo in just a bit. But a few things are in a policy. We have a repository to install from, which is called a repo. We have what to install, and that's called a task. And then we look at what to hand off to after the operating system deployment. We call that a broker. A broker could be Puppet, could be Chef, or the no-op broker if we don't want to hand off to anything. We also add in stuff like root passwords, host names if we need to. We can also add in node metadata, which could be pretty much anything, and tags, which are very, very important, and I'll show you why they are important in just a bit as well. So it will look something like this. You will have a name for the policy. You will show which repo you're installing from. That might be an ISO source or a URL, but we call it, for this one, it's CentOS. A task, which we for this one call CentOS as well, which is essentially installing CentOS on our boxes. I'm not using a broker here. I could just put in name Puppet and point it to one of the Puppet masters in my environment. I put in a host name, which is host.lab.purevirtual.eu, and my very, very secret root password. I put in a max count showing this is the maximum amount of servers, physical or virtual, doesn't matter, that I want to deploy using this specific policy. Because maybe I don't want 100 CentOS servers out there, I just need 10. So I can put a max count on there as well. Then I can add node metadata that can be used during provisioning, and you can add whatever you want in there. You can add who is awesome, and that's all of you. I've also added my favorite Mystery Science Theater episode, which is Puma Man. You can add in whatever you want. Then we have the tags. The tags are very, very important because the tags are essentially taken from the facts, the hardware facts that we get from the server when they boot up the first time. And based on those tags, we choose which server we want to install an operating system on. So what happens when you boot up a server or an entire rack or a data center for that matter? It might be a total greenfield environment and you're booting up rack after rack. So the servers boot up and they boot up a Razer microkernel using standard iPXE boot. It feeds all the hardware info back to Razer using factors, standard factor facts, something like this. You can actually see all the node facts every time you talk to Razer using its API or the CLI that also actually uses the API. You will get information like how many processors do we have? What IP address have you been given by the DHCP server? Are you virtual? How large is your drive? Is it an SSD? Is it made by Seagate or Samsung? So a ton of information that you can gather from standard factor facts, and all of those can be made into tags. A tag might look like this. We create a tag called small, and the rule when to apply this tag, or actually tag a server with this tag, is if it has one processor, so you can see the processor count is 1, and I want it to be virtual as well. You can have an and or relationship here, so you can create tags that where you specify a lot of information in an and fashion, but you can also make a lot of assumptions in an or fashion if you want to. If a server, when it boots up, it matches these tags, it will automatically get tagged with this specific tag. Lots of tags. But it's very, very important to understand how the tags work because they make Razer work. So what happens if you have many servers that look alike? Let's say you have 100 of these servers that have one CPU and they're virtual. Well, Razer, when you apply the policy, it grabs the next available one out of the pool, so to say, that have that tag applied to it. This works very well if you have a lot of your servers that are supposed to run the same thing, same operating system, same type of host name, same type of IP addressing scheme, and so on. But it might not apply if you want more control over what actually gets installed where. So Razer, the standard setup of Razer is perfect if you just want a pool of, let's say, a rack or 20 racks where you can just choose a new server and you're not really, you don't really care where stuff gets installed. But what if you have, let's say, 3 racks of servers, they all look alike, and you want to install the top 10 in a rack with VMware vSphere, and you want to install the bottom 10 with a Cloudera Hadoop deployment. What to do? It's kind of hard with Razer because you just pick and choose randomly out of the pool, so you don't really have any control over how to deploy it. Another example, still have 3 racks of servers. They are not alike, meaning you will have different types of pools of tagged servers. But you want to install the top 5 with OpenStack Compute, the next 5 with VMware vSphere, next 5 with Cloudera Hadoop, bottom 5 with, let's say, EMC Scale IO. And you want each group to be in a certain order as well, so you want the top one to be called OpenStack Compute 1, 2, 3, 4, and so on. That's not possible right now. Well, it is now since about 2 weeks ago, but we'll get to that. You might also want something like this. This is a picture I did for the blog post that we put up on the Puppet Labs blog about 2 weeks ago, where I want Scale IO, a software storage system, installed on a few of my servers, and I want the first top ones in one rack and the bottom ones in another rack. I want to install OpenStack mixed as well, and same with Pivotal Cloud Foundry. This is really hard to do if you don't have any control over where you actually deploy the operating systems. And by the operating systems, I also mean all the services on top of it. Enter Razer microkernel extensions. This is a really small thing that they added in for the last release of Razer in May. That was just made for making it easy to add new facts. So you could actually add new facts to your Razer microkernel without having to rebuild your, build your own, roll your own microkernel every time, which a lot of people were doing. So they just added this as a fun thing, and I read up on it and I said, that's perfect. That's exactly what we want to use. A Razer microkernel extension is a very, very simple thing. You essentially use a script or a few binaries, a few libraries to collect more facts about a node. Those facts might be interesting facts like server ID, some unique ID, maybe some BIOS information that the regular facts don't get, maybe RAID configurations, stuff like that. You add all those binaries, the libraries, and the scripts into a few defined folders, you zip it up, you point it out in a Razer configuration file, and I'll show you how to do this in a bit, and all of a sudden we have profit. It's awesome. So the way you create your MK extension, you have a bin directory for all the binaries, so they are actually added to the path of the microkernel, and they get downloaded every time you boot up the microkernel. So if you update your microkernel extension, maybe add even more facts, it's going to be downloaded every time you reboot a server, and actually more often than that, once the server is there and just waiting, it will download the updated microkernel if it finds one as well. Libraries added to proper library paths as well, and you can also load external facts if you want. How to configure Razer to actually look at this extension file? Very, very simple. You can see the bottom line there, extension zip, and you just point it to the zip file where you have all your binaries, libraries, and scripts for your facts. Very, very simple. You add that in, restart the Razer server, all your nodes are now downloading the microkernel extension zip. This is all in the documentation up on GitHub. It's all documented, very well documented, I gotta say, on how to actually create these microkernel extensions if you have something that you want to build as well. So what did I do? I created a server locality microkernel extension. I'm using standard Razer functionality, standard factor functionality, but I added some facts in there. So I used an open LLDP Ruby facts file created by Mike Arnold. I added some binaries and libraries for Fedora 19 for LLDP, so I could actually run the LLDP service and query it. What happens then is that all my nodes, all my physical nodes out there that have this microkernel extension will actually query the switches that they are connected to. This means that I can easily see if a server is connected to a specific rack switch. It might be rack 47 switch 1, and it's on port 1. If that's what I get out of it, I actually know that that server is my first server in the rack. This, of course, applies only if you have proper racking and cabling standards. So this applies very much to larger environments where you want to provision large, let's say a pod of 20 racks or something like that, and you have a standardized racking and cabling setup. It's much easier to have this and use this. So I've added the binaries and libraries and everything, the Ruby script to get the facts, put it in a zip file, pointed it out, and the result I got was this. So the facts that I now get from all my servers actually contain all the information I need to see where in a rack, where physically in a rack I have a server. So for this one, the example here, I am connected to a switch called Razer Switch 1. It's just my Razer rack. And it's connected to port ID 17. So I know that this is server 17 in that rack because I have that cabling scheme. I can also see that which VLAN I am on, and I can also see the MTU information if I want to. All you need to do on your switches is to enable LLDP. LLDP is included in pretty much any switch that you buy on the market today. I'm using Arista switches for this, but you would see a similar output from Cisco switches, HP switches, you name it. What will happen when we use this is that we can still have the random pools where we say, okay, I got a few racks over here. I don't really care how they are deployed, just deploy them. And then I can have a standardized, really rigidly set environment as well. So we can have both, where we can have a random pool and we can also have one where we have control over what goes where. So it's not an or scenario, it's actually an and scenario. So you add functionality without removing anything else. So you could get both and enjoy the benefits. You guys want to see a demo? Good. So this is my Razer environment. This is my Razer server that I have right now. And in this one, I've created the microkernel extension. So I'll show you the extension, first of all. This is what it looks like. It has a binary folder, has a facts.d folder, and a library folder. Within the binary folder, you can see I have everything I need to actually get LLDP up and running as a service and then to query it. In my library folder, I got some libraries that, that the binaries are needing as well. Very simple. Within that library, I also have a Ruby folder. And within that, we have the factor folder, and there's our OpenLLDP Ruby script, which is run, queries the LLDP daemon that then talks to the switch on the rack. All of this is contained in the zip file that you see here. All of this is public on GitHub as well, so you can just go out and use it. In the blog post I have up on the Puppet Labs blog or on my blog at purevirtual.eu, there's a few setups and how to configure it as well if you want to try it out. So what happens there is that we get information from our nodes that we can then, we get hardware facts from our nodes that we can then create tags from. So you can see here in this example, I got 3 physical nodes, node 1, 2, and 3. And you can see that they are tagged with a specific switch, and they are tagged with a specific physical port as well. So I know which server this is in a physical rack because we have a standardized cabling scheme. You all have that, right? Sure you do. If you don't, you should, because then you can reap the benefits out of this. Those tags, let's have a look at those tags. Let's do this. So for the first one, the switch tag, I'm just looking at the fact that I get from the node. I'm not even talking to the switch here. I'm just talking to the node and looking at the facts that I get from the node, and I can see a specific fact, and if it matches Razer Switch 1, which is my switch in that rack, then this tag gets applied. Same thing with the other tags. So looking at Gigabit Ethernet 17, for instance. I'm looking at the fact for the LLDP neighbor port ID on a specific network card as well. And if that matches Ethernet 17, perfect. Then I know I'm on gigabit Ethernet 17, and I also match Razer switch 1, then I know which rack I'm in. If you name your switches correctly, let's say you have data center name, rack name, then you actually know which data center the server is in, the rack the server is in, and the port ID, so you can actually see server locality, not just in a rack, but in a full data center. So using this and let's say rack tables for populating rack information, you can easily put together a really nice graphical view of how your environment looks and what is installed where. That makes it very easy if you have to troubleshoot physically something, if you have to troubleshoot a cabling issue or maybe a hardware issue, maybe you need to switch out a few drives. Okay, which server is it that I'm installed on? Well, it's easy to see because we actually know that by the location in the rack using this method. With these tags, we can then create policies as well. So these policies actually use the tags that we have created. Let's have a look at one of them. This policy will deploy CentOS, uses a repository that I have created, and it only applies to the server, one specific server, that has these tags applied to it. It's in a specific rack in one specific location. So I can pinpoint exactly which server it is and what to install on that specific server. So you can be very, very precise while still reaping all the benefits from the pool functionality within Razer. So you actually still have both. So with this, you can get a full environment of anything into your data center. So if you wanted to install, let's say, an OpenStack environment and you wanted it to be properly propagated throughout a rack or throughout several racks, and you want them named properly as well, you can easily do that. One way I've made sure that this specific environment is for Scale.io. Scale.io is very, very picky on IP addressing schemes and host names and stuff like that. So I actually included some information in the deployment piece here for Scale.io. I'm going to show you this. Within this, I've also added a hostname pattern and a very secret root password, as you can see. And based on that hostname pattern, I can then apply my Puppet manifests that then apply networking like IP addressing, MTU, size, and everything like that, and also applies the software that is supposed to be on that specific node with a specific host name. So if you wanted multiple OpenStack controllers, let's say one controller per rack, you could just say, okay, I want you to be called OpenStack controller. It doesn't really matter with host names anymore. You can just add in information like that. You could also, if you wanted to, you could feed back data into Factor once they're deployed, so they can actually have a Factor fact that then decides on what to install on that specific node. So not just host names, you could have other stuff as well. So with this, you can have a fully controlled environment, fully controlled deployment of whatever you want, while still having the benefit of the pool functionality within Razer. Razer has quite a lot of tasks that it can use, right? We looked at, this one is using CentOS. We got Red Hat, we got Debian, we got Ubuntu, we got Windows, both Windows 8 and Windows 2012. I don't know who would install Windows 8 in a server environment, but fine. In a few days, hopefully within a week, we will have Core OS functionality within Razer as well. So you can deploy Core OS using Razer on whatever hardware you want. So if you want to play around with a proper distribution for Docker, you can use Core OS and deploy it using Razer. We've got the code ready. We're just waiting for to create a full pull request, and then we're pretty much ready to go, I think. All right. Do we have any questions about what you've seen? How many people here are using Razer? Let's start with that. Hands up. Few, okay. How many here have tried Razer at one point or another? About the same then, okay. Razer is really cool, and yes, we have a question there in the back.
Instead of setting up servers in some sort of standardized way on every rack, we would like to be able to guarantee that, for example, two nodes in a HA proxy pair are not in the same rack, as we have accidentally discovered on occasions during power outages. So how would I apply this sort of network awareness to sort of guarantee that condition?
That's a great question, so I'll repeat it. The question is about how can I make sure that I have different services, like an HA proxy, deployed on different racks. So if I have a power outage, I'm not impacted by it if it just impacts one rack. Is that correct? So the way you can do that is that you can define here that during the deployment, you could add a new factor name, a new factor fact, or a specific host name on two different racks. So you could have rack 1, gigabit Ethernet port 1, and rack 2, port 1. Those two servers will be HA proxies. So you could define it like that and make sure that they are HA proxies, and then you wouldn't have that issue with a power outage where you might have HA proxies in just one rack. Is that a good enough answer? Yeah, so with this, you could definitely spread out your services and make sure that you're more fault tolerant than before. So looking at the picture I had here, like this, because you don't, if you have a large enough environment, you definitely want to spread your services across racks. And with Razer today, you don't have that control unless you're using the microkernel extension. Because you might actually have all your stuff installed in one rack, and if something happens with that rack, well, all those services are down. While in this environment, if you deploy it like this, you can actually make sure that you are have higher reliability and higher uptime for your services that you're delivering using different products that you want to install. So that's a really good question. Thank you. Another question here. You got the mic?
How might the strategy change with blade servers? Because this looks very much like your traditional rack mount, rack pizza boxes, but with blade server network architecture being slightly different. How does that change the strategy?
That's a really good question. I haven't really thought of that. So yeah, that's no, that's a really good question. Let's have a look at that and see how we can implement it, because that's definitely something that we want to address as well. Not all customers will be using, as you say, pizza boxes like this, right? But blade servers as well. Blade servers will have hardware configurations onto certain internal ports. So maybe we could get information from that. But let's have a look at that.
So my thought along those is, especially if you look at something like Cisco UCS, where it's service profile based, that profile itself is able to move along, integrating Razer, and assigning it to a service profile. I don't know if the microkernel extensions doesn't sound like that really applies there, but unless, because the MAC address, of course, it's assigned, but it's pooled, so it's not necessarily a one-to-one. It's a different kind of challenge. I'd be very interested to see how might be able to leverage that type of functionality.
I think if we can query the host profile that's applied to a specific host, if we can query that using an external fact, then we can definitely do something like that. So as long as we can query it using a REST API or a CLI command or something like that, and we can get that information, then we can feed it into Razer and use that. Because then if you moved that specific blade or moved that specific host profile, we could just reapply it as well. So yeah.
Right, so you're essentially replacing that LLDP query with a net new query that's still providing the facts.
Yep.
That get applied.
Exactly. That's a really good question. We got another question here to the right first. Yes.
So extending that then sort of to a virtualized environment, is there some way that Razer can determine if it's running on a virtual machine, what the hypervisor is that it's running on, perhaps
Yes.
some of the other parameters that are available there?
Yes, there is. So Razer has functionality to verify if it is virtual or not. As you can see here in the facts here, is virtual equals true. So we can know that this server is actually virtual. If it's not virtual, then we know as well. In some cases, you can actually see the virtualization platform as well. So we can know if it's running on VMware or VirtualBox.
Can you find? Is there a way to find out exactly which hypervisor it's running on? Like you know what switch you're connected to, but I'm trying to figure out which hypervisor you're actually on.
Yeah, so I was looking into that while creating this, and that's actually an issue that we see with virtualization because we've abstracted away all that. Because it might be that virtual machine is on one host right now, and in 10 minutes it's on another host. So all that is abstracted away. Same with access from a virtual machine to a physical LLDP switch port. That's actually denied. So you can't, from a virtual machine today, see the physical LLDP information that you have. No hypervisor that I know of, that I've tried it on, actually allows that. So right now we're pretty much stuck with virtual machines. So this will apply mostly for physical environments for now. You got a question in the back as well?
So something that I've encountered, and I'm wondering about the use case here, is when we're setting up a new data center,
Yep.
frequently we either have no information or faulty information from whoever did the actual rack and stack. So right now we have to do sort of this global throwaway kick of everything, have them all run Puppet and check their facts into Puppet DB, and we then feed that back into our asset tracking system. Mm-hmm. And I'm wondering, is it possible to have Razer nodes, instead of only sending their facts back to the Razer master, to then use this LLDP information and everything else that this machine kind of gathers about itself and have that report into Puppet DB? Because then we could harvest that information, and instead of having to rely on humans scanning barcodes, we can simply have the servers stand up and report back information about themselves. Can that be done?
So the microkernel right now, it only talks to Razer when replying back. The factor fact that I'm using is essentially just a factor fact. So if you have LLDP deployed on your servers today, you can actually get that fact directly from your physical host without rebooting them or booting up to Razer or anything like that. So I would say that the easiest way for you, the least invasive way to get all that information would be to deploy LLDP and then just run that open LLDP fact so you can feed that into the Puppet DB. Rebooting all your servers, have it fed into Razer, and then exporting that into Puppet DB. That's also an option, but it's more invasive, I would say. So for that brownfield use case, I would definitely deploy LLDP, very, very small environment, and just grab those facts, and then you can remove LLDP if you don't want it anymore. Any other questions? All right. Then I would like to thank you all for coming to this session. If you have any questions, please let me know. I'll be here all day. If you want to reach out to me on Twitter @virtualswede or jonas.rosland@emc.com. Thank you very much.
Thank you.